Most food is organic in nature, though it contains minerals. Many drugs are composed of organic molecules. Plastics too. Nowadays, chemists are exploring nature to develop eco-friendly products. People are aware of the importance of organically produced food. The organic compounds in each family have a similar chemical structure and a similar chemical formula. Each family of organic compounds forms what is called a homologous series. There is a variety of organic compounds which can be classified into groups of similar compounds, such as alkanes, alkenes, alkynes, alcohols, amines, ethers, etc. These groups are called homologous series. Members of each group are similar in formula and properties. For example, the group of alkanes has methane, ethane, propane, butane, pentane, hexane, etc. as members. The successive members of the homologous series differ in their molecular formula by a CH2 unit. Look at the structures of two consecutive members of the homologous series of alkane, A and B, given here. Count the number of carbon and hydrogen atoms in each. What do you infer? The difference between the two members is CH2. The carbon chain in the molecule octane can be represented in many ways, as shown here. A homologous series is a family of organic compounds having the same general formula and similar chemical properties. Let's consider the homologous series of alkanes. What are the common properties of members of this series? Members of any homologous series have the same general formula, similar chemical properties, similar structures, similar names with a common ending, and similar methods of preparation. Their names, methane, ethane, propane, butane, pentane, and hexane, have the common ending ane, A-N-E. Let us look at their molecular formulae. All have the general formula CnH2n plus 2. Look at this table. The molar mass of methane is 16 gram per mole. The molar mass of ethane is 30 gram per mole. When we find out the difference in molar mass between two successive members, it is 14 and constant. This difference corresponds to the molar mass of the linking unit CH2. We also notice an increase in molecular mass as we move from methane to hexane. Since the molecular mass increases in any homologous series, we can observe a gradation in physical properties, that is, melting points and boiling points increase with the increase of molecular mass. Other physical properties, such as solubility in a particular solvent, also show a similar gradation. But the chemical properties, which are determined solely by the functional group, remain similar in a homologous series. The hydrogen atoms attached to the carbon chain can be replaced by any other functional group. For example, the hydroxyl group replaces hydrogen in alcohol, and its properties predominate over those of the carbon chain. In alkenes, the chemical properties depend on the carbon-carbon double bond present in the carbon chain. Isomers are compounds having the same molecular formula but different arrangements of atoms in the molecules. The molecular formula of butanol is C4H9OH. It has various structures as shown here.
The IUPAC names are butan-1-ol, 3-methyl-butan-1-ol, 2-methyl-butan-1-ol, 2,2-dimethylpropanol.
All of them have different structural formulae and the same molecular formula, C4H9OH. Hence, all these compounds are called isomers of butyl alcohol. Let's study how these isomers are classified. We can discuss three types of isomerism at this stage, namely chain, position, and geometrical isomerism. Isomers differing by the nature or by the length of the carbon chain are called chain isomers. Let's consider the three molecules A, B, and C. All of them are butyl alcohol with the same molecular formula, C4H9OH. Since the nature of their carbon chain is linear in structure A and branched in structures B and C, they are called chain isomers. Isomers differing by the position of functional group attached to the carbon atom are called position isomers. For example, 1-butanol and 2-butanol are position isomers. OH group is attached to the first carbon atom in 1-butanol and to the second carbon atom in 2-butanol. 1 and 2 in the name of the compounds represent the position of the OH group attached to their carbon chains. Isomers differing by a change in geometrical positions are called geometrical or cis-trans isomers. Let's see what this means. When substituent atoms, such as chlorine atoms, occupy the same side of a double bond, the resulting molecule is said to have a cis isomer. When the chlorine atoms occupy opposite positions, the compound is called a trans isomer. Such isomers, differing by a change in geometrical positions, are called geometrical or cis-trans isomers. These two isomers have different boiling points. The cis form boils at 60 degrees centigrade and the trans form boils at 48 degrees centigrade.